Now, electrons don't really do this. They don't really orbit in a circle in an atom. But by assuming they do, we can get a lot of really good results. And that was done early in the 1920s, basically. And then the whole picture of electron behavior was refined and worked out. And it turns out that they can't be thought to go in circles. But again, oh crap. A useful but not entirely accurate model of the way electrons behave in atoms is that they are in sort of circular orbits like planets around the nucleus of the atom. Okay, that's not really so, but it's a useful model and we get a lot of good predictive results out of it. Well, anyhow, okay, if the diameter of the orbit of an electron in a hydrogen atom is 1.06 times 10 to the negative 10th meters, that would be 1.06 angstroms, and angstrom being 10 to the negative 10th meters, a very convenient unit to use if you're talking about atomic dimensions. But you don't need to know that right now. Okay, 1.06 times 10 to the negative 10th meter diameter. At an average speed of 2.2 times 10 to the 6 meters per second. Now that's really fast. That's 2 million meters per second. And 2 million is a hard number to imagine, and 2 million meters per second even harder. Let's just say that's about 6% the speed of 7% the speed of light. Okay, it's really moving. Okay, so these electrons are moving very, very fast in a very, very tiny, around a very, very tiny circle. Question is, how many times would they go around that circle in a second? Okay, how many revolutions per second? So, what do we think? Well, each revolution, they go all the way around a circle, so they go a distance equal to the circumference of the circle. A circumference of the circle is 2 pi, or is pi times its diameter, 2 pi times the radius, pi times the diameter. Pi being defined as the ratio of circumference to diameter. It's the number you would multiply by diameter to get the circumference of a circle. That's the definition of pi. It's not 3.14, not 3.1416, it's not 3.1415927 or whatever it is. It is the ratio of circumference to diameter of a circle. Okay. By that definition, we know then that if we multiply pi by the diameter, we get the circumference. Okay, well, pi times the diameter is pi times 1.06 times 10 to the negative 10th meters. And we could write that as 1.06 pi times 10 to the negative 10th meters. Now, distance in 1 second is 2.2 million, or 2.2 times 10 to the 6th meters. So, how many times will go around this circumference in a second? Well, the time required, or the number of times that this circumference will divide into that 1 second distance. Okay, so the number of revolutions is the distance in 1 second divided by the distance in 1 revolution, which is 2.2 times 10 to the 6 meters divided by 106 pi times 10 to the negative 10th meters. Okay, well, we can work out the numbers. That's 2.2 over 1.06 pi. Pi is a little more than 3, so this is a little more than 3. And if we work that out a little bit more, we can see that 2.2 divided by 3 is about 0.7. So 0.7 isn't a bad result. 2.2 is a little higher than 2.1, which is what 3 would divide 0.7 times. 1.06 pi is a little bigger than 3, so 0.7 is not a bad estimate. We could refine the estimate. What about the exponent? Well, the laws of exponents tell you when you divide 10 to the 6th by 10 to the negative 10th, you get, okay, when you divide, you subtract exponents. You get 10 to the 6th minus negative 10, and that gives us 10 to the 16th. So we have 0.7 times 10 to the 16th revolutions. It's a lot of revolutions. This isn't quite in scientific notation, and I wouldn't reject this solution. I wouldn't penalize it, but unless I was specifically asking for scientific notation. But we want to be able to convert this to scientific notation. The reason this isn't in scientific notation is that the number out here is not between 1 and 10. Okay, the number here has to be at least 1. It has to be less than 10. And this number is 0.7. Okay, so we can fix that easily enough. 0.7 is 7 divided by 10, which is 7 times 10 to the negative 1. So we can replace 0.7 by 7 times 10 to the negative 1, and that's then multiplied by 10 to the 16th. Then our 10 to the negative 1 times 10 to the 16th gives us 10 to the 15th, and now our number is expressed as 7 times 10 to the 15th. It's completely equal to this number, but now it's in scientific notation because this number is between 1 and 10, and this is a power of 10. So 7 times 10 to the 15th times, I try to explain how big that number is, but it's probably going to be beyond everybody's grasp. It's kind of beyond my grasp, but I probably have a little better idea of how to break it down. It's a huge number, lots and lots of revolutions, a number that's so big that most of us just can't really get a handle on how big it is. There's one more question in this problem, which is, okay, how many times does the electron go around? What's the average velocity of the electron in its orbit? You say, well, speed's 2.2 times 10 to the 6 meters per second. Velocity is change in position divided by change in time. Okay, the change in position of an electron as it goes around one orbit is 0. It's back where it started from. So velocity is defined as change in position divided by change in clock time, not distance divided by change in clock time. Actually, it's defined as rate of change of position, which is change in position divided by change in clock time. So average velocity is 0, since the change in position in any orbit is 0.